Let's start by this video by taking a look at this reaction, A plus B goes to C plus D, and then this reaction where C plus D, the products of the first reaction, go to A plus B. Notice carefully, we took this reaction, we modified it to this reaction, and the question is, when we make this kind of modification, how does the equilibrium constant change? Now, in this video, we're going to talk about three different types of changes of equilibrium constant. Okay, so how the equilibrium constant changes when you modify a reaction. I'm going to list out the changes and then I'm going to go into detail about each one. So in the first scenario, if you take A plus B and you gives you C plus D, and the rate constant, not the rate constant, the equilibrium constant for this is K1, and you take this equation and you reverse it. Okay, so if you reverse the equation, that means the products become the reactants and the reactants the products. The equilibrium constant for this reaction is going to be the inverse of the equilibrium constant for the starting reaction. Okay, so K2 would be equal to 1 over K1. Let's take a look at the next scenario. So if you take the first reaction out here and you multiply it by a factor, so let's say we multiply it by a factor of 2. So I'm going to take 2, I'm going to put the entire reaction in parentheses. I'm going to go ahead and erase this. Parentheses should be around the entire reaction. Then the equilibrium constant for this reaction is going to be equal to that equilibrium constant raised to whatever factor you multiplied it with. So that's going to be equal to K1, which is that equilibrium constant raised to factor of 2. And the third scenario out here is, let's say I have two reactions, A plus B gives me C plus D, and let's say that has an equilibrium constant K1, C plus D, Then I have another reaction, E plus F gives me G plus H, and let's say the equilibrium constant for that one is K2. If I add these two reactions together, I'm going to get A plus B plus E plus F as my reactants, and my products are going to be C plus D plus G plus H. So that's my overall reaction. My equilibrium constant for the overall reaction, let's call that K3, is equal to these two reactions multiplied with each other. And what I mean by that is the equilibrium constants for those two reactions multiplied with each other. So K3 would be equal to K1 times K2. Now that we've kind of taken a look at the three scenarios, scenario 1 is if you take a reaction and you reverse the reaction, then the equilibrium constant for the reversed reaction is the inverse of the equilibrium constant of the original. In scenario number 2, if you take the reaction, you multiply it by a certain factor, then the equilibrium constant for that is equal to the equilibrium constant of the original reaction raised to that factor. Scenario 3, if you take two or more reactions and you add them together, the equilibrium constant for the overall reaction after the addition would be equal to the product of the equilibrium constant of the constituting reactions that came together to form the overall. Let's take a deeper dive into this and understand the why behind this. Okay, let's start with this reaction. Let's say you have N2 plus H2 gives us NH3, and we're going to balance that reaction. So that's 3 out here and 2 out here. Okay, and let's say the equilibrium constant for this reaction is K1. Now we're going to reverse this reaction. Okay, so to reverse this reaction, we're going to make the products the reactants and the reactants the products. So that would be 2NH3 gives us N2 plus 3H2, and let's call the equilibrium constant for that K2. So let's go ahead and write the expression for the equilibrium constant for this reaction. So K1 should be equal to the products raised to the coefficients, so the concentration of the products, so concentration of NH3 raised to 2 over the concentration of the reactants multiplied with each other raised to their respective coefficients. There you have it. So that's for the first one. Let's write the equilibrium constant for the second one. So K2 is equal to products raised to their respective coefficients over reactants raised to the coefficient. Okay. Now, if you kind of compare K2 and K1, you can see if I take the reciprocal of K1, that means if I take this entire thing and I divide it by 1, I actually end up getting this expression, because see, and this term goes on top and this term goes below, which is indeed is the case. Therefore, I said in the beginning that when you take a reaction and you flip it, meaning you reverse it, then the equilibrium constant of that new reaction is the reciprocal or the inverse of the equilibrium constant of the original reaction. Let's take a look at case 2. So in the second scenario, we're going to take this reaction, we're going to multiply it by a factor. So let's say we multiply this reaction by a factor of 2, and let's see what we get from it. So if we multiply that with 2, then we get 2N2 plus 2 times 3, 6H2 plus that gives us 2 times 2, 4NH3. Let's go ahead and write the equilibrium constant for this new reaction that we got. So that's K is equal to products raised to their coefficient over the reactants multiplied with each other raised to their respective coefficients. There you have it. So now once we have this, if we kind of take a look at this and kind of break it down a little further, let's see what we get. So this can be written as, see, all of them are raised to some power that can actually be split up. So let's say write this as NH3 raised to the power of 2 times 2 over N2 raised to the power of 1 times 2 times H2 raised to the power of 3 times 2. Okay. Now see, all of these, if I just kind of box this, if I take that entire expression, notice carefully, everything in red is actually raised to the power of 2. So I can write this as NH3 raised to the power of 2 over N2 times H2 raised to the power of 3, and this whole thing is raised to the power of 2. But what is this? This is nothing but K1. See, that's identical. Therefore, we can say that K is equal to K1 raised to the power of 2. So, what is that 2? 2 is simply the factor that the original equation was multiplied with. So, in summary, if you take any equation at equilibrium, you define the equilibrium constant, you write it down, and then you multiply that with a certain factor to modify the equation. The factor you multiply it with is going to appear as an exponent in the new equilibrium constant. So basically you write the equilibrium expression and then you raise that to this factor to get you the new equilibrium constant. So let's take a look at this scenario where you have two reactions. Of course, these are fictitious reactions. Where you have two reactions. Reaction 1 has an equilibrium constant K1. Reaction 2 has an equilibrium constant K2. And what we're going to do is we're going to add these reactions together. And if we add them together, the overall reaction is going to be, the B's cancel out. So therefore you get AA gives us CC. And the question is, what is this equilibrium constant in terms of this one and this one? And as we've described before, this equilibrium constant, when you add reactions, the equilibrium constant of the overall reaction is equal to the product of the equilibrium constant of the reactions that you added together. So let's go ahead and try to prove this. So if you take a look at the first scenario out here, the equilibrium constant for this, the expression would be B concentration of B raised to the power of B over concentration of A raised to the power of A. For the second scenario, it would be concentration of C raised to the power of C over concentration of B raised to the power of B. Now, when you add these reactions together, okay, first of all, you can actually write the equilibrium constant out here for this, the expression. Just go ahead and write it out. So that gives us C raised to the power of C and A raised to the power of A. Now, if you take a look at this just visually and compare it with these two, notice carefully how this plays out. K3, which is equal to C raised to C over A raised to A, is equal to, essentially K2 is out here, right? So you have, if I take this expression, C raised to C over B raised to B, and if I multiply it with this expression, B raised to B over A raised to A, notice carefully, the B's cancel out, giving you essentially C raised to C over A raised to A. But what is this? That is nothing but K2. And what is this? That is nothing but K1. And there you have it. The overall reaction, the equilibrium constant, is equal to the product of the equilibrium constants of the reactions that you added together to make that overall reaction.